Hi, this is Aisha Ghaffar, and I will be presenting my Teach 1 assignment for comparative effectiveness. What we are looking for in this assignment is in two parts. The first question has three parts. The first part is identifying which two patients in the following table could serve as matched controls for the cases. The second part is selecting the possible controls randomly using the lowest random number provided. And then the third part is using a Kaplan-Meier survival plot to see which patients had no falls. So, how we do the first part of question 1 is that there will be two patients who are going to be identified, and they will be matched controls for the yellow highlighted patients. Matching of cases will be based on the age of the patients, and the controls will be chosen based on the lowest random numbers. Since we are basing the cases on the age of the patients, we first need to find the standard deviation between the ages of the patients. To find out standard deviation, it's best to use Excel and insert all the data from the chart shown. After inserting the data underneath the column of ages, it's best to enter in the formula for standard deviation, which is equal STDEV.S, and then you highlight the ages between patient ID 1 through 9. Upon doing that, the standard deviation for the age ends up being 8.89. Next, we will find the lowest random number. To find that and calculate it, we have to look at the two case patients. For example, in the first case, the patient's age is 65. We will add and subtract the standard deviation by the age 65 to see what the range of ages is. Upon subtracting the standard deviation from 65, the first age is 56.11, and adding the standard deviation gives us the age of 73.89. The patients that fall in within the range of the first patient's standard deviation are patients 2, 8, and 9, which are highlighted in orange. Then we will do the same for the case patient 2, whose age is 84, and do the similar calculation as patient 1's, which gives us the range of 75.11 to 92.89 years, where patients 4 through 7 fall in within that range. The two cases with the lowest random number for case 1 were cases 8 and 9 with 0.16 and 0.17 random number. And then the two cases with the lowest random number for case 2 were cases 4 and 6 with 0.7 and 0.72. We will then continue on to the last part of question 1 by conducting the Kaplan-Meier plot. To conduct that for the first part is going to be for the cases, which we're only observing for two patients since there's only two cases. In order to calculate this, we will look at it over the 4-month period. Since there were only two patients, only one of them had experienced a fall, which was in the 3rd month. And based on the chart that I made, just follow the same approach and kind of see how once the first patient falls in the 3rd month, in the 4th month you're reduced by one patient, and then that one patient doesn't fall in the 4th month, so that's why it stays the same. We will then continue and do that for the 4 controls, the same Kaplan-Meier plot. And with the 4 controls, since we're looking at 4 patients over the 4-month period, it was only in the 2nd month that amongst the controls, patient fell. Once a patient experiences a fall, they are then reduced, which is why the number in the 3rd month reduces to 2, because 2 had already fallen. And then finally, you conduct the actual plot on the chart. And the way to conduct this is comparing the percentages of never fallen. And you can enter in this data in 2 columns in an Excel sheet and highlight the 2 columns which shows the cases and controls percentages. Upon doing that, you just press on the insert bar in Excel, and then you click on the line charts and go with line with markers, and then Excel will generate the plot that I have inserted in my slide. The second part of the assignment deals with looking at decision trees for 2 different clinicians. There's 3 parts to the second question. The first is, what is the expected length of stay for each of the clinicians? And then the second part is, what is the expected length of stay if Dr. Smith were to take care of Dr. Jones' patients? And then the third part is vice versa, if Dr. Jones were to take care of Dr. Smith's patients. The way to find the missing probabilities in the decision tree is to subtract the given probabilities by 1 and finding the alternative probabilities. For example, since it was 0.70 for one of the probabilities, the alternative would be 0.3 since they both equate to 1. And that's just one example. And to conduct that, you do that throughout all the missing probabilities. To calculate the expected length that a doctor will see their patient, you have to multiply that by the possible routes. For example, like I circled one of the routes in slide 10. It is circled in orange, and that is the MI to the CHF calculation, and the probability is we calculate 0.25 times 0.15 and we get 0.04. Once we get the probability of 0.04, we multiply that by the length of stay, which is 4.5 days. Upon calculating that, we get the sum of 0.18. We do that to the following routes that are possible through the tree. Upon doing that, we get a sum of 3.64 days as the expected length of stay for Dr. Smith. For the second part of the question, we will look at what the expected length would be if Dr. Smith sees Dr. Jones' patients. To calculate that, we find all the similar routes, and once we find the similar routes that both the doctors share, we will then use the probabilities for Dr. Jones that he had on his tree for Dr. Smith. Once we do that, for example, the MICHF has a probability of 0.85 and 0.65 on Dr. Jones' chart. We use that for Dr. Smith. Once we do that, we find a probability of 0.55, and then we use the same length of stay that Dr. Smith uses, which is 4.5. Once we calculate that too, the probability of stay is 2.475 days, which is about 2.5. Then we do the same throughout the rest. So to get the expected length of one doctor's for another doctor's patients, we use the same length of stay for the doctor but we just use the other doctors' probabilities. And then moving on to the third part of question 2, which is finding the expected length if Dr. Jones sees Dr. Smith's patient, which is the vice versa of the second part. But except in this last part, the only difference is that there are 2 roots that occur in Dr. Smith's chart that don't occur in Dr. Jones. So what we do is we put them down twice, which are the first 2 roots listed, which is MICHF. So since you're doing it twice, you divide it by 2 for the probability, but you get the same probability for both. It's just the length of stay which is different. Lastly, we will discuss the importance of comparative effectiveness. Comparative effectiveness is a very helpful way in displaying patterns between various subjects, and a control in comparative effectiveness helps us see the normal in a case. For example, in question 1, we saw the pattern of the percentages fallen by creating the Kaplan-Meier plot, and then the controls were one of the aspects of the plot, which we found through calculations. Lastly, comparison between probabilities shows us which subject is more effective, or more likely what route can be really effective in a business or infosystems plan. For example, in question 2, we were comparing the expected length of stay for Dr. Smith and Dr. Jones, and then we checked if they were to see each other's patients, and then we see all the possible outcomes, and then we can decide which outcome is the best fit for a system.